Yeah. So here it was given that to find the arc length and area of sector with the given radius r and central angle. Now we have to remember one formula. Length of arc is given by theta by 360 into 2 pi r. So if we have an arc like this, arc is nothing but the path of a circle. The path of a circle. So assume this as a whole circle. Assume this as a whole circle, and this as angle theta, and we know that the whole angle in circle will be 360, and to find only this angle or this radius, this length, okay, this length we have to find. So the total length will be 2 pi r, because the total length of circumference of circle is given by 2 pi r. Total length is given by 2 pi r, but only a specific arc length is given by theta by 360 into 2 pi r. That means a percentage of that angle. The total angle will be 360. Out of that we have only angle theta, so it will be theta by 360 into 2 pi r. Similarly, the total area will be pi r square. So therefore area of sector, particular sector, area of sector is given by theta by 360 into pi r square. So we are just calculating the percentage over the 360 degrees. So here if you observe carefully, it was given that theta value as 150 degrees. So 150 by 360 into 2 pi r. So 2 into we can put pi as it is, whereas r is given as 12. So 0 0 gets cancelled. 12 ones are 12 times 3, and that's it approximately. It will be 15 to 30, 30 by 3, 3 ones are 3 fives are 10 pi, 10 pi. And similarly we can do it for this also. So here the length of arc is equal to theta by 360 into 2 pi r. Theta is given as 5 pi by 12 into 360, whereas here we have to put pi as 180 radians, so it will be 5 into 180 into 2 into pi into r is given by 3. So 180 ones are 180 twos are, so 2 gets cancelled. So 3 ones are 3 fours are 5 pi by 4. Similarly, area of sector is given by theta by 360 into pi r square. So it will be 150 by 360 into pi into r is 144. So 3 fives are 3 twelves are 12 ones are 12 twelves are. So area is given by 60 pi feet square. Like this we can find. So you just have to remember these formulas. Arc length is given by theta by 360 into 2 pi r, and area of sector is given by theta by 360 into pi r square. This we can find by using calculator. Sin A is equal to 0.53. So A will be sine inverse of 0.53. Directly you can use calculator for all these three problems. Yeah, this is somewhat interesting. Here coming to first problem, here we got one side which is maybe opposite or adjacent, because if you observe from B it will be opposite, and if you observe from C it will be adjacent. And the side which is opposite to right angle is known as hypotenuse. So let it be opposite, let this be adjacent. Okay, now since this is 28 degrees, this is 90, and we know that sum of angles in a triangle should be 180. So if you remove subtract 90 and 28 from 180, you will get 62 degrees. Okay, so angle B will be 62 degrees. I'm telling how I'll get the value, how I got the value of B. So we know that in a triangle sum of all angles should be equal to 180. So angle A plus angle B plus angle C should be equal to 180, and out of these three angles, angle A is 28, angle B we have to find, and angle C is given by 90 is equal to 180. So angle B is equal to 180 minus 28 minus 90. So if we do it, you'll get 60 degrees as the answer. And to find BC side, okay, so when you are observing from point B, you need to find BC, which is adjacent side, and you know opposite side, so you can apply tan theta. So tan B is equal to opposite by adjacent when you are retrieving from point B. So opposite is 29.3 and adjacent, you know, we don't know, right? Yeah. So first what we have to find, adjacent is, yeah. So but here we got to know the value of B value. So B is given as 62, right? So tan 62 degrees is equal to 29.3 by adjacent. So adjacent side is given by 29.3 by tan 62. Okay, so we can directly use the calculator to find this value. Similarly, we can find AB by using either sin theta or cos theta. Okay, so coming to B question, it is 5, it is 12, and the side opposite to right angle is known as hypotenuse, which can be taken as x, and we know that we can apply right angle triangles theorem, Pythagoras theorem. So it will be opposite square plus adjacent square is equal to hypotenuse square. 144 plus 25 is equal to x square. So 169 is equal to x square, and x is equal to 13. So this will be 13. He is asking what is measurement of angle A. Measurement of angle A. Now we can tell that sin A is equal to opposite by hypotenuse. So sin A is given by 5 by 13. Sin A is given by 5 by 13. So therefore A is equal to sin inverse of 5 by 13. Similarly, from here if you take the angle, it will be sin B is equal to opposite will be 12, hypotenuse will be 13. So 12 by 13. Okay, so it depends on the observation point. If you want certain angle, if you have to find certain angle, we have to observe from that point. Even this is also same. So here we got the adjacent side and we don't know opposite side, and we got hypotenuse side. So by applying Pythagoras theorem, opposite square plus adjacent square is equal to hypotenuse square. So x square is equal to 19 squared minus 13 square. So it will be given by 361 minus 169. So if you subtract 361 minus 161, it will be 200, and if you subtract even 9, it will be 191. So x is equal to root 191. So the answer for AC is root 191, which is approximately 14 or 13.9. And if you want to find A, since we know from A it is opposite, this will be adjacent. So from A we know opposite and hypotenuse, so I can apply sin theta. So sin A is equal to opposite by hypotenuse. So A is equal to sin inverse of opposite by hypotenuse. Similarly, if you observe from point B, this will be adjacent. So sine B is equal to adjacent. Sine B is equal to uh, yeah, AC. So AC will be root 191 by 19, or if you can find cos B, so even that is also good. Opposite by adjacent by hypotenuse, cos B. Yeah. When a hockey player is 35 feet from a goal line, he shoots the puck directly at the goal. The angle of elevation of the when which the puck leaves the ice is 7 degrees. The height of goal is 4 degrees. Will the player score a goal? So let it be some goal. Okay. So when a hockey player is 35 feet from a goal line, so it is given by 35 feet, and the height of goal is given by 4 feet, and the angle is 7 degrees. Angle is 7 degrees. So will the player score a goal? That means we just have to calculate when the ball is going beyond this height or when the ball is going below the height. We just calculate. We can just calculate this height. So assuming that we don't know this height, let it be 7 degrees and it be 35 feet. Okay, now since this is opposite and this is adjacent, I can apply tan theta. So tan theta is equal to opposite by adjacent. So tan 7 degrees is equal to opposite by adjacent. So therefore h is equal to tan 7 into 35. So if I calculate this using calculator, so tan 7 degrees approximate value is 0.122 into 35. So it will be 4.29. So this height is 4.29, whereas the height of goal is only 4 meters, 4 feet, and from this, if he kick at an angle of 7 degrees, so the maximum the ball reaches is here, 4.29, which is beyond. So he cannot kick a goal. He cannot kick a goal. So that's one important point. So because when he's kicking at a 7 degrees angle, which is at a distance of 35 feet from the goal, the ball will be reaching at a height of 4.29, but the goal is only at a height of 4 feet. So the ball will not reach the goal and it will be a foul or something else. So there will be no point for it. Okay, thank you.